All right, today we're going to talk about part 2 of the statistical process. Yesterday we did part 1. We learned about the first 2 steps of the statistical process. Today we're going to do steps 3 and steps 4. We're still answering the question, what is the statistical process? Make sure you're following along and completing your notes, filling in the blanks, and be sure to write questions on the side when you have a chance and to write the summary at the bottom when we're done. Okay, step 3 is to analyze the data. So we're analyzing the data. Analyze just means look at it and see what it means. We're putting it in graph form. So today we're going to look at several different kinds of graphs. Some of these might be the types of graphs you'll want to use later with the data that you're collecting this week. The first one we're going to look at is a dot plot. And you might recognize this from last Friday when we did the M&M activity. We did something very similar. A dot plot is a data display that shows discrete data on a number line with dots, X's, or other symbols. Now you might recognize that word when we talked about discrete and continuous graphs. It's very similar. These are going to be broken up. They're not continuous. Okay. Now the way that this works, you might want to fill in the X's. Apparently they asked the question how many siblings that we have. And they asked several people. Let's think. 1, 2, 3, 4, 5, 6, 7, 8. They asked 8 people. That 8 people was their sample population. Now what I want you to think about is each one of these X represents a possible answer. There's either 0 siblings, 1 sibling, 2 siblings, and so on. Okay, here's what I want you to do. Turn to a neighbor and answer the question, how many people had 4 siblings? Okay, you should have said there are 2 people because there's 2 X's here. That means 2 people answered they had 4 people. All right, now think about our mean, median, and mode lesson. Mode means it happens the most. So turn to your neighbor and answer the question, what was the most popular number of siblings that people had? Okay, you should have said 3 because there are 3 X's here. No other numbers of siblings had 3 people say they had 3 siblings. All right, so we're going to move to the next graph. Okay, the stem and leaf plot. Sounds kind of like a tree. It doesn't really look like a tree. Stem and leaf plot is a graphical method used to represent ordered numerical data. So if you remember back when we did mean, median, and mode, the median, we had to list out all the numbers in order. Well, this already does that for us. All right, it is a short way to write a bunch of numbers. So instead of writing out 20, 85, 87, 87, 94, and so on, you can write it in this nice, neat package called a stem and leaf. Now the way this works is this number here represents the tens digit, and this number represents the ones digit. So your stem is your tens digit, your leaf is your ones digit. So looking at it again, this is your 8 or 80, and this is your 5. So 85% is what this person scored. Now be careful, this is not 8,577. This is 85 or 87 and 87. It means these 2 7s mean 2 people scored an 87 on this test. All right? So let's see what you know here. Oh, by the way, before I forget, this right here, if we have a tens in the 10 digit, this carries into the hundreds. So these are the people that got into the hundreds. All right, so here's what I want you to do. Turn to a neighbor and answer this question. What was the mode of this data set? What happened the most? You should answer 95, because look at this, 3 people scored a 95. 9 here, 5 here means a 95, another 95, and another 95. Well, here's the next question. Turn to your neighbor. What was the highest score on this test? Okay, you should have said 102. So again, this is a 10 in the tens place, so it's 100, and this is a 2. Okay, now turn to your neighbor and answer this question. What was the lowest score on the test? Okay, lowest score, not a 2. It would be a 20 because there's a 2 and a 0. So it's 20. 2 is the tens, 0 is in the ones place. Okay, so that's the stem and leaf plot. We're going to move on to our next type of graph. We have histograms. Now, this may look like a bar graph, and you're kind of right. We'll get into the similarities and differences later. But here's the definition of a histogram. A histogram is a graphical way to display quantitative or numerical data using vertical bars. Okay? It still kind of sounds like a bar graph, right? Oops. Now, here's what I want you to notice, though. This is not just one quantity, like how much pizza or how many people like Pizza Hut the most, how many people like Papa John's, and how many people like Papa Murphy's, and so on. All right? This says from 100 to 150 centimeters. So how many trees approximately are in the height of 100 to 150 centimeters? Okay? And then this is a range, another range, 150 to 200. So you can tell a lot more trees, 30 to be exact, have a height between 150 and 200. What's weird about these graphs is usually we're used to heights being over here and numbers being down here. Okay? This is a number range of height. So about 30 trees are between 150 and 200 centimeters. All right? Now here's what I want you to answer. What height range, so turn to your neighbor and answer this question. What height range is the most common? Had the most trees in this height range? Okay, hopefully you answered this one. 50 trees were from 250 to 300. So the answer to my question was 250 to 300 centimeters. All right, now answer this question. About how many trees are between 300 and 350 centimeters? Turn to your neighbor and answer that question. About how many trees are between 300 and 350 centimeters tall? All right, I'm looking at this range right here, 300 to 350, and that's about 10. Okay, can you see that there? It's about 10, maybe about closer to 11 or 12, but we're close if we said 10. So that's how histograms work. Now let's look at them a little closer. The similarities and differences. Similarities between histograms and bar graphs. Both have vertical bars that show data. Both have numbers on the left side and the bottom, and both have labels. Okay? Nothing new there. But here's the differences. Like I said, the bars are touching on histograms. There is a range. Okay, and the height of a histogram bar represents the frequency. Like I said, it's not their height. It is how many achieve that. It's a little bit like a line or dot graph. Okay, and the bottom of the histogram is intervals, meaning ranges from here to here. Okay, between, what was it, 50 to 150 and so on. Okay? Now, what is step 4? We're going to interpret the results. Interpret the results. So look at your data and see what we can conclude from it. So distribution is a part of this. A distribution is the way in which the data are spread out. Now, if you look at this chart, you can kind of see different distributions. All right? You'll notice the tallest is over here on one side. Okay, we would call that a skewed left. Over here, most of it's on the right. We call that skewed right. What we want is most of it to be kind of in the middle. You might have heard of a bell pattern. That means the most are in the middle, which is kind of what we go for. Otherwise, we think that it is skewed a little bit, if it's a little bit off to the side. So, other words to describe data. We have clusters. Clusters are areas where data are grouped together. Gaps are areas where there is no data, kind of like phone coverage. Peaks are values that contain more data points than the values on either side of it. And outliers are data values that lie a large distance from the other data. All right? Oops. So if you look at data, clusters are going to be where it's all kind of grouped. Gaps, you have a little bit of a gap in your data. Maybe a lot of students scored an 80 and 90%, and then there's another group that scored maybe 60%. There's a gap there. Peaks are high numbers in one area and then right next to it really low numbers. Okay, maybe it's after lunch and students are falling asleep. That might be a peak, and then a valley. And then outliers are data values that lie a large distance. So if you have one person who scored a 20 and everyone else is in the 80 range, they might be an outlier. He'll give you a chance to get all that copy down and write questions to the side and a summary before we give you a chance to practice.